class, today we want to look at forces. Basically, we'll look at moment of a force, principle of moment, and we also look at the procedure for triangular forces. So I'll start with moment of a force. First, let's remind ourselves what a force. A force is a quantity that has magnitude and direction. A force is a vector quantity. So everything we're talking about on the board, we're going to consider magnitude, which is size, and also direction. Alright, and what's the moment? The moment of a force is defined as the product of the force and the perpendicular distance from the point of action or point of rotation. Okay, don't forget, it's something you know, just as a reminder, force applied by perpendicular distance from perpendicular to the force. Okay, then we also have what we call principle of moment. That has to do with when you have a system and you find your sum of clockwise moments, it must be equal to sum of the anti-clockwise moment, which I'm going to demonstrate. I'm going to take you through in this diagram very soon. That's the first condition. And second one is that the total upward forces must be equal to the total downward forces. Those conditions we will say, those conditions are prerequisites for an object to be in equilibrium. Okay? What I'm trying to say is that principle of moment cannot be applied on a system that is not in equilibrium. Equilibrium means there is no resultant force and there is no resultant moment. So quickly let's see. Now we have a system here, we have a pivot and we have a ruler, and weights W1, W2, and W4 were suspended on the system. So let's look at the first. Since the system is in equilibrium, we can say that the total upward forces must be equal to total downward forces, meaning that this R, which is acting upward, must be equal to W1 plus W2 plus W3 plus W4. That's the first condition. That you must understand. Now, the second one is what I told you earlier on, that some of the clockwise moments equals some of the anti-clockwise moments about the same point. So we must recognize. Now let's take a moment about the pivot. Now if I do that, remember that initially we have 5 forces acting. Now when you take a moment about a point, any force acting at that point is going to be ineffective. What I mean by that is that its moment is going to be 0, because moment of force R about this point will be force R times 0. So this is not going to be active in this. So I only have W1, W2, W3, and W4 that are effective. So let's first of all identify which one of them are clockwise about this point and which one of them are anti-clockwise. That's very simple. You know that if I want to find moment of W1 is going to be W1 multiplied by this distance. In this case, if I have distance of this as x1, W3 this as x2, I have W3 to this pivot as x3, and I have W4 to this point as x4, which means that W1 must act this way, so W1 and W2 will then be anti-clockwise, while I have W3 and W4 as clockwise. Therefore, so we can say the sum of clockwise moments will be equal to W1 multiplied by the distance. Distance of W1 to the pivot will be x1 plus x2. So that gives us W1 into bracket addition of distance x1 plus x2. Okay? That's the first one. Plus the second force is moment at which is W2 multiplied by x2. It is x2 because the distance of W2 to the pivot is x2. That's why we need only that force. So that's for the clockwise moment. Now, sum of anti-clockwise moment will be W3 multiplied by x3, W3 x3 plus W4, okay, multiplied by the distance distance of W4 to the pivot is x3 plus x4. Alright? So if you are given any question and you want to just equate these two equations and you find any unknown. Alright? So that's the procedure for determining this moment. Now let's go to triangular forces. Now if you have three forces acting on a system, the three forces can be used to represent the three sides of a triangle, but they must be in order. What do I mean by being in order? Being in order means that, like I'm showing on the board, please look at my diagram on the board. Being in order means the arrows must follow each other. You can see if I have this triangle labeled as A, B, C, side A, B, C. Side AB arrow is going up. The end point is where BC starts from, and where BC stops is where CA. So the arrows are in order, right? So let's quickly solve this question on the board using triangular forces. So let's represent these forces on the board with a triangle. And I think I can use one on the board as well. Okay? Let's see. Okay, I'll do another one. So the vertical one, this line going down, which is 50 dt. The one F1, you can see that F1, we should also include angle. Let's say this is 45 and this is 30 degrees, okay? Okay? Alright, so F1 is acting this way, is going this way. And the last one, which is 75, is going this way. So that means we're going to have something that goes this way. Alright? So we need to recognize where the angle should be. Now to do that is very simple. Look at my F1. My F1 is making angle 45 with the vertical. Okay? This is my F1. And looking at the vertical, now this will then be 45 degrees. My 75, which is going this way. If you observe, my arrows are in order because look at it, this is coming down, also my arrows are already in order, and I have this as 30 degrees. So what we need to do is to solve this triangle, I'm using that, of course, 45 plus 30, when you have together you have 75, take it from 180, then you have the angle, which should be 105 degrees. Okay? Is that okay? So from there, you can use your cosine rule or sine rule or cosine rule to determine F1. So that's the first thing I would like to say about representing the forces with the sides of the triangle, which is called triangular forces. Now we can also resolve this system. We can resolve it with resolution of forces. We can resolve it horizontally. Now if we resolve horizontally, what do we do? What will happen is that, you know, this is 45 degrees, this must be 45 degrees. This is 30, this must be 60. Okay, because addition of these two give 90, this also give 90 degrees. Okay? So if we resolve horizontally, what do we get? I'm going to have 75 horizontally, that will be 7.5 Newton cos 60 degrees. Cos 60 degrees because I'm resolving horizontally. And you know what? Once I do that, this 7.5 Newton is acting this way. That will be equal to F1 cos 45 degrees. Okay, because two of them can be acting equally. Now, when you do horizontal resolution, 50 Newton is acting vertically, so it's not going to be part of this system. Now, the second one is resolving vertically. Okay, when this is done vertically, in this case, F and 7.5, they will resolve and be added together going upward, while 50 is coming downward. So then we have 7.5 Newton cos 30 degrees plus F1 cos 45. cos 45 degrees, okay? I told you, you will resolve them, you know, particularly and solve them, they are going upward, and it now be equal to 50 newton, okay? So in this case, we have two equations. Of course, even from this puzzle, you can get your F1. So this is the procedure for resolving your forces, both vertically and horizontally. So how we say that you need to apply this to some questions in your textbook, and if there's any clarification, feel free to let me know. Thank you so much. I wish you all the best. See you some other time.